All right, we're back. We're still on page 197. We are taking a look at parametric equations, and what we're trying to do is make things move back and forth. Instead of just going from A to B, it's going to go from A to B and back to A. And what we did last time was we had this path. It's going to be the same path this time. So we're going from negative 5, 8 to 15, 12, and then back to negative 5, 8. So we came up with this figure, a couple of assumptions. We assume that we're going to get to point B halfway through. So if it's a 40-minute round trip, we'll get there at 20. We also assume that we hit the halfway point of each trip. So from A to B, the halfway point, and then from B to A, the halfway point. We assume we hit those halfway through each of those trips. Once we make those assumptions, though, we can do this. We got the semi-surprising result that you end up using the same trig function both times, but it's not really surprising because it is a line segment, so it makes sense that we'd be using the same parameter. Usually we just use t, and then you set both equal to t and then equal to each other, and then you're done. Here, we set both of them equal to cosine of pi over 20t. I made that silly mistake last time. And then you just kind of like go from there. So it's not surprising that you're using the same trig function, but it's initially kind of surprising. All right, we're at a set of parametric equations. Start at B, take 20 minutes. So if you'll indulge me, I'm just going to copy this figure and use it again. And I have to erase some stuff because now it doesn't take 40 minutes, it takes just 20. And actually, I think I may have answered this question last time accidentally. So we're starting at B, so this will be t equals 0. And then it's 20 minutes round trip, so this we're going to get here at t equals 10. If we get there at 10, we should have gotten here first at 5, and then again, so think about it, it's t equals 0, t equals 5, we're here, t equals 10, we're here, t equals 15 will be here, and then t equals 20. So this is going to be 15. Then we get back there at t equals 20. Okay. So the period is going to be 20, which is 2 pi over b. So in this case, b actually is going to be pi over 10. Unlike last time when I just said it was pi over 10, and it was a mess. Now, I'm going to write the equations without doing the components. So I'm just going to think, like, what is x doing, right? So for x, okay. For x, you start here at 15. That's the biggest x you're ever going to have. And then you decrease and then eventually increase. So you start at a maximum. Therefore, it's going to be positive cosine because that's what starts at a maximum. How about for y? So this is the thing. We already kind of know that y is going to be cosine because if it's supposed to be a line segment, they have to have the same parameter. And if one of them has cosine with its parameter, then the other one will too. The question is it positive or negative cosine? Because that could vary. But y is starting at the biggest and then getting smaller and then getting bigger again. So also going to be positive. That starts at a maximum. Therefore, cosine as well. Okay. So let's see if we can work it out. So our equations. So the sinusoidal axis is basically the midpoint. So for both of them, you're going to end up using the midpoint. So 5 for x and then 10 for y. Sometimes people find that confusing, but remember, it's when you plug in 0, you get the starting point. It's not that this is the starting point. This is not necessarily where you're starting. So when you're writing a linear equation to go from point A to point B and be done, it is the starting point, but not in this case. In this case, it's going to end up the sinusoidal axis. The reason is we start here rather, right? And we go to 5, and then we go down to -5, and then we go back up. We start at a maximum, so we can go 10 away, and then cosine of pi over 10t. If I plug in 0 for t, I get the cosine of 0 is 1. I get 10 plus 5 is 15, which is where I'm supposed to start. So this is not your start. Your start is what happens when you plug in 0. You got to keep that in mind. And then for y, 10 to 12 is 2, and then 10 to 8 is 2. So it's going to be plus 2 cosine of pi over 10. I think that your ability to write equations from trig graphs is huge. Like that's one of the most important skills you can have. I think this is going to work. I will check it on GeoGebra in a second. First, I'm going to do the next problem, and I'm going to steal the picture again. because I think it saves us about, 18 seconds. Every second counts, man. The analysis videos are packed. There's a lot. So when we can steal a second, steal a second. All right, what are we doing here? Start at the midpoint. Okay, so we're gonna start here. So this is gonna be t equals 0. Head toward A, so we're going this way. All right, so if it takes 20 minutes, all right, so if it takes 20 minutes to make a round trip, so our round trip is here, and then we go like this, and then we go back, right? So we're at 0, it should be 5, 10, 15, 20. Okay, so I'm gonna fill those in. T equals 5, 10, 15, and then back to t equals 20. All right, let's think about what each of them is doing. So, well, first of all, 2 pi over b has to equal 20. So b again, pi over 10. It's funny that it's been pi over 10 twice, and I got pi over 10 incorrectly the first problem. So that was good. That was key. All right, what's x doing? Starts in the middle, goes to a minimum. It's actually a bad example because x and y are always doing the same thing, and like that doesn't need to happen. Like if our line looked like this, where this was a and this was b, if we started here, x would start in the middle and decrease. It would be a negative sign. And then y would start in the middle but increase, so it would be positive sign. Like that's possible. It's just whoever wrote the notes, I don't know what they were doing. They kind of messed it up, but we're starting in the middle and decreasing. So I wrote all the notes, by the way, just in case. In case you think I'm like, picking on somebody. I'm not. I'm picking on me. Middle, oh my God, middle to mid to minimum. So that's going to be negative sign. And then y is going middle to minimum. So why am I writing minimum? I don't know. Middle to minimum. So that's also a negative sign. So it's a bad example, but what are you going to do? Gee, what are you going to do? Could someone ever possibly change it? X is, y is. So remember, it's not necessarily the starting point. It's just the midpoint, because when you plug in 0, that's when you get your starting point. So x will start at 5 and y will start at 10. And then they're both negative signs. So x is going to be negative 10 sine pi over 10t. And then this will be negative 2 sine pi over 10t. All right. I think that's going to work. I don't know why I used 20 twice. I feel like if I could do these again, might be some changes. Let's answer this, and then let's go to GeoGebra, and then we'll be done with this page. Not necessarily this idea, but this page. You either, okay, let's say you use sine comma sine or cosine comma cosine. And it's great because both are periodic. So they do return to a point. Like they kind of naturally make a round trip. They think of the unit circle. The unit circle is literally a trip. It's a round trip. But now we want to be on a line, so we're using sine and sine, which will make a round trip, or cosine and cosine, which will make a round trip. So you could have plus or minuses also. I mean, I'm not really concerning myself with that here, but you could. Like any combo of like plus minus, whatever. So this will always start at an endpoint if you're using cosines, because cosine either starts at a maximum or a minimum. You've got to be at an endpoint of your segment. Here you'll always be starting in the middle, and then you have to really be careful about which way you're supposed to go. Should you use positive or negative, because it's less obvious with sine, I guess. So I'm going to go to GeoGebra. I'm going to graph both of these and just put a point on and move it and see if it worked. And also, I still have the last GeoGebra file that I made, so I'm actually just going to modify it a little bit. So what do I need to change? I'm going to duplicate. I'm going to hide everything. And then up here, I think what I need to change is, so I'm checking the first one we did in this video. So it should be plus cosine of pi over 10t. You get some weird results as you're like changing, oh my God, changing it, because it graphs it with each edit that you make. You get interesting things. 2 minus 5, what do I have here? 5 plus 10, and then 10, oh, plus 2. Plus 2. Okay, so I think this should take, it's a 20 minute. So if I do b of 0, it should give me the starting point. I did want to start there, so that's good. And then if I do b of 10, it gives me this, which is where I wanted to hit and then turn around. So if I do b of v, and then let's drag v, let's go. Yeah, this is doing exactly what we wanted. So good job, us. All right, let's hide all that. Hide, hide, hide. Let's duplicate. And then this one actually, I'm actually just gonna delete it and do it again. So let's do this, curve. It's really annoying to change sines to cosines because it like, this, the stupid template pops up and then you gotta like fight with it. And no one has time to fight with templates. T, especially when it's like not super annoying to do this. So 0 to 20 will give us the entirety of the thing that we want. Let me hide this. If I do c of 0, it should give me the starting point, which should be the midpoint. Okay, that's good. And then if I do c of 5, I should get negative 5/8 because that's the direction that I went. And I do. If I do c of 10, 15, I should get the other endpoint. And I do. All right, let's put a point on here and drag it and see what happens. So at 0, I should be at the midpoint this time. What is this random point here? Oh, G, yeah, makes sense. J is the point that's going to move. All right, so it should go toward H and then back and toward I and then back and then just keep going forever. So we did it. So this is a really cool thing that you can do to make a point go back and forth. I recommend you play around with it. See if you can come up with some examples where you're using like positive cosine and negative cosine, or positive sine and negative sine. Like mix it up, try to make things happen. But anyway, we are done with this. So I'm gonna end this video here and I will be back in the next one to do some more. So I will see you there.